Okay, in this video I'm going to cover probability distribution, chapter 4.1. So we are going to explore discrete probability distribution. Discrete probability distribution is the distribution that is not continuous. It's discrete, you can count it, okay? So what we are going to learn in discrete probability distribution. First of all, we are going to learn the fact that probability of each value of the discrete random variable is between 0 and 1, or same thing between 0% and 100% altogether. And the sum is going to be 1 because 100%, right? Be it 0.3, and then it can be 0.4, and then another 0.2, and then 0.1. It still give you 1, which is 100%. All right? So, how we are going to construct discrete probability distribution? We are going to make frequency distribution for possible outcome, find the sum, and blah, blah, blah. You can read all this. So I rather move to the practicing problems because it's better see one time than hear 10 times. You can read this. There is nothing special here, but I would rather move to everything is written. I'll show you in practice. So constructing a discrete probability distribution. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. And how do we know 150? This frequency we have. If we add them up, we should get 150. I don't know if they showed here the whole amount of employees, but if you go through, you should get the total amount 150 of employees. Okay, individuals were scored, were given a score from 1 through 5. Here it is. Okay, 1 through 5, where 1 is extremely passive. I can rather underline extremely passive. And 5 is extremely aggressive. So outliers, either one end or another end. A score of 3 indicates neither or, balanced out. So construct a probability distribution for the random variable of x and graph the distribution using histogram. Okay, let's do it. So what do we have? Total, we know 150. First, at the score 1, we have 24, and then 33, and then 42, 30, 21. All right? So to find probability for each score, what percentage of an entire company makes it, we take the frequency, 24, let's say, we had with score 1, divide by total 150. We get 0.16 with score 1. Accordingly, with score 2, we get total frequency is 33 people were scored with 2. So if we divide by 150, we get this much. So and the rest, so if we add all together, we should get 1, which is 100%. Okay, might as well, since I did it, 114, we should get 1. Okay? So, here it is. We have it. Okay? And we are getting 1 altogether with the probabilities, which will make 100%. Okay, now here we have the graph, the histogram. So with the score 1, we had how many? 16%, 22%, and the highest is score 3, which is balanced. Let me see. Score 3, and indeed, it comes out balanced. See? it's 0.3. Let me use this color, right? Free, score free, and then going down again. All right, so based on histogram, we can say the most 28% of people are balanced out. Mean of discrete probability distribution. This probability distribution that we looked, the table a while ago we did, how to find the average. To find the average, we are going to use this formula, sum of mu is equal sum of x times probability of x. So practically we are taking x and then multiply by its own probability, x1, and then x2, multiply by its own probability, and then blah, blah, blah. How many we have, I don't know. Xn multiplied by its own probability. And at the end, so once we add them, we are getting sum of x probability of x. Okay? And that will be the average of discrete probability. All right. Next. Finding the mean. So here we have example. This is our x. This is probability, x, probability, score probability, score probability. So what we're going to do, let me see if it will show. I don't think it doesn't show. So we are going to take 1 times 0.16, 2 times 0.22, 3 times 0.28, 4 times 0.20, 5 times 0.14, and then if you summarize them, you should get 2.94, and that will be the average for discrete distribution. Okay? Mean. Now, the variance and standard deviation, I believe I should have under the problem for chapter 4.1, in the comments, there should be link to the calculator. But this is our formula for variance, and square root of variance always gives us standard deviation. Okay? Where x is our score, it's our element, mu is average of the population, and probability of x is the probability of the elements in the sample size. Okay. So here we're going to find the probability, find the variance. I will show you how to do by hand, but I'm pretty sure I placed the link in the comment under the problem 4.1, and you can use it to find the standard deviation and variance. Okay. So here it doesn't show, so I will do that for you. Here is our formula, sigma squared, sum x minus mu times 2 times probability of x. So first we need to find x minus mu, or we have already here x minus mu. Then next we are going to do, 1 second, I made a mistake, this is supposed to be squared, x minus mu squared. Here we should get x minus mu squared, so which will be negative 1.94 squared, negative 0.94 squared, 0.06 squared, and so on. Okay, and then here, this x minus mu squared information, we are going to multiply by, so all this multiply by probability of x. This number, whatever we get, multiply by probability of x. And the probability is, for the first one is 0.16, right? Which is 0.16. The second probability is 0.22. So practically whatever you get here square, you multiply by 0.22. Here, whatever you get, negative 1.94 square, multiply by 0.16, and so on. And at the end, you add them up. you get the result at the end here. Okay, let's see if we have example and we can do it. So, mu average, the average for the expected value. This is our variance. Okay, we will get in there also. Average for the discrete random variable or discrete distribution, mu is equal sum of x times probability of x. We also call at the same time expected value, E of x. Okay, which means we are kind of forecasting it. All right, so what we are going to get with this, how we are going to use this formula. Here is example. I'm going to amaze you with the problem that taken from life, and that's how to play the lottery and how much you use to lose, how much what's your chance to gain. Okay. So we have at the raffle 1,500 tickets total. We have total 1,500 tickets and sold for $2 per ticket. Okay, and we have 4 prizes, 500 prizes, $500, $250, $150, and $75. Okay, so let's see what we have. You buy 1 ticket, okay, out of 1,500, 1 ticket is yours. What is the expected value of your gain? What's the chance you are, how much you can gain? Let's do it. So if total prizes, we said 500, 250, 150, 75, and 0. You don't gain anything. Now, if you gain $500 prize, you are realistically gaining $498, right? Minus $2 for the ticket. If you gain $250 for prize, you realistically gain less $2, less $2, less $2, and here is loss. $2, you don't gain anything, right? Okay, so we are going to calculate expected value. Now, if you gain 498, you are gaining, it's going to be only 1 ticket, right? Which is 1 out of 1,500. You are gaining 248 less $2, right? From 250, you still gain only 1 ticket, which is 1 out of 1,500. Same way, we keep going, 1 out of 1,500, 1 out of 1,500. And here, if you lose $2, it's going to be how much? Minus these 4 tickets, right? 4 tickets are carrying price. So 1,500 minus 4 tickets, the with price, it's going to be 1,496 and over 1,500. Now, we know that average is equal, expected value or average is equal, where is it? Sum of x times probability of x, okay? Let me write down sum of, here it's written down, okay, let's write down here, sum of x times probability of x, and that's our expected value or mu also. Okay, how we're going to calculate? Here is mess, I'm going to rewrite it so you can understand and read, okay? So, let me see. Sum of x times probability of x. So x is going to be 400. Oops, what did I use? Okay, I used the shade instead of pen. So $498. That's the value of our x, and we multiply by probability, which is probability 1 out of 1500. Next, another one, 248, because see, we have to add them, it's sum. 248 times 1 over 1500 plus 148. Let me see if we have on this side written. No, we don't. Okay, 148 times 1 out of 1500 plus 73 times 1 out of 1500 and minus, because we have negative 2, minus 2 times 1496 over 1500. If you do all this math, you are going to get negative $35, which tells you, here it is, in average, you are going to lose $35. What does that mean if you are going to lose $35? Tickets cost $2. If you are going to lose $35, that means the cost of ticket is going to be how much? 65 cents. The ticket, it costs realistically 65 cents. So they are adding $35 and sell $2. What does that mean? Besides of you lose $35 every single person, that means this $35, the organizer of this lottery is gonna walk away getting $35 from your pocket. So he doesn't even care who will win the prize, who will lose the prize, because per person, if he is going to get $35, and we have 1,500 people, now figure how much money he's gonna walk away. Now you tell me who is gonna be the true winner. The one who will win 498, or the one it's gonna win $35 times 1,500. Let me see, $35 times 1,500. You're gonna walk away with $2,025. This is a true winner. Okay, so just so you know, playing in lottery, this is what you should expect. And that's pretty much it, expected value. So we learn how to figure out the mean, right? Mean is equal sum of x times probability of x. This is our mu, mean. Variance, we have it, right? Variance is going to be equal sum of x, difference of x and average square times probability of x, right? And this is variance, and standard deviation, sigma, is going to be equal square root of sigma. And we calculated, find the expected value of the discrete probability. Okie dokie. Just don't forget, when you solve the problem related to chapter 4.1, underneath you should find the link to the online free calculator for discrete probability distribution. Okay.